Can you see my screen, Sufyan? Okay, good. So now let's start the class. It's already 10 minutes late. Before beginning the class. So, sir, I have already started nucleophilic substitution, right? Mariam? Hello.
Yes, sir.
So you were in last class in the when sir has started nucleophilic substitution.
No, I think I was not there.
Okay, no problem. So let's start the topic and Sufyan, we will start. We will start from from starting only. So you try to understand the concept. Okay. So nucleophilic substitution by name, we are getting that something is substituting, right? Something is coming in place of something.
Yes, sir.
Ha. And nucleophilic substitution, the word is nucleophile there. So then what is nucleophile? Mariam, can you say?
Uh, Electron, they attract electrons.
Nucleophile. Wait. First, let me write the name of the topic. Nucleophilic substitution reaction. Substitution reaction. In short form, we say it SN reaction. Okay. Substitution, and this is nucleophilic substitution. So nucleophile, from the word you can say nucleophile means from the word nucleo comes from nucleus. Nucleus has positive charge, right? Nucleus is positive charge. Yes, be responsive or turn on your cameras. There are only two options left. So nucleo means positive, and philic, yeah, phil means lover. So positive lover means they have abundant, or they have abundant negative charge. They have abundant, you can say negative charge on it. Or no, not negative charge. You can say negative charge, but the more appropriate will be abundant electron with it. Okay. So since they have an abundant of electron with them, so they want to attack on positive thing, right? Because neutral species are always stable. So since they have abundant electron, so they want to neutralize it, so they will attract positive thing, right?
Yes, sir.
So that is why this is called nucleophilic. And there is a substitution which we will see in 5 to 10 minutes. So we will understand what is nuclear. But the definition, first of all, let's write the definition. Which I already told. I'm going to write it down. You can also write it. Noted? Sufyan, have you noted it down? Sufyan. Mariam,
Yes, sir.
have you noted it down?
Yeah.
Sufyan, I cannot hear you. Are you there?
Yeah.
So are you feeling sleepy?
Yeah.
So why you're not responding? So see, from the definition, as I have told you, in a reaction in which a group of substrate, what is substrate? I'm just going to tell you, is replaced by nucleophile, which is called nucleophilic reaction. So what is a substrate? Substrate is a organic reactant molecule. Organic reactant molecule. Reactant molecule. Reactant. This is a molecule on which the reaction will take place. Okay. So it is represented by Rx. What is R? R is alkyl group and X is halogen or any living group. Okay. We will note these down. Don't worry. Okay. Then there is nucleophile. And there is nucleophile. Reaction will take place between substrate and nucleophile. I have already told you the definition of nucleophile. Okay. Hmm. So nucleophile are electron rich species. They are electron rich species. So obviously they will attack on positive thing. Electron rich species. So let's see an example, because if you will see example, you will understand it more, more easily. For example, there is chlorine attached with a carbon atom. Okay. And we are reacting with it like Cn minus. Can you see this Cn minus have extra electron on it, abundant. This is electron rich species, right? Can you see?
Yes.
So this is an electrophile. Okay. And this, what will happen? And this is a substrate. This is an organic molecule, substrate. This is in reactant side, and actually on this is the main compound on which we are going to do experiment. So on this substrate, we are using this nucleophile and attacking on this. And how we will understand that where it will attack? You can understand it by this concept. This chlorine is very electronegative atom, right?
Yeah.
This is the after fluorine, oxygen, and nitrogen. Chlorine electronegativity is at 4th position in the periodic table. So chlorine is very electronegative atom. So they will attract the shear pair of electron towards itself, right? The more electronegative atom will obviously attract the electron itself, right? So this will attract electron towards itself. So it will have a partial negative charge, and this carbon, this will have partial positive charge. Tell me if you understand this point.
Yeah.
Mariam,
Yes, sir.
Yes, sir.
this is kind of inductive effect. Amna, are you understanding? Are you getting these things?
Yes.
Okay. So, so tell me, this electrophile will attack on which side? On this chlorine or on this, this carbon? Tell me.
Carbon.
Huh? I cannot hear you. This is a this has rich in electron. This has a rich electron in it. Okay, this is electron rich species. So it will attack on this partial positive charge, positive charge or partial negative charge. This negative will attract on this negative thing or
भाई
this
सर के
positive
स्टिचेस
thing.
वगैरह लगे हैं।
हाँ,
तालिम सर के स्टिचेस वगैरह लगे हैं।
क्या लगे?
और बैठने में क्या मसला उनको?
हाँ आमना, आमिना, आमना, सॉरी, आमना, सुफियान,
Yeah.
what do you think? This negative charge electron rich species will attract on this negative thing or this positive thing?
Positive.
Yeah, positive. Mariam, what are you doing?
Sir, I'm here only.
Amna, have you understood this?
Yes, sir.
No, sir. Or yes, sir. I'm not. It is not clear.
Yes, sir.
Okay. So, so this will attack on this thing. Okay. So what will happen? What will the product? This will get attached with this carbon and it will remove this chlorine ion. Okay. This will attach on this carbon and this will remove this chlorine ion. That is why, since we can see chlorine has been substituted, that is why it is called substitution reaction. Okay, that is why it is called substitution reaction. Fine.
Fine.
Okay, and since this is which is attacking, this is nucleophile is attacking. So since nucleophile is attacking, so this is called nucleophilic substitution reaction. Have you understood this?
Yes, sir.
Okay. So I hope you understood this point. Okay. And this chlorine, since this has left the primary this substrate, so this will be called leaving group. Okay. Sufyan.
Okay.
Okay. So I'm giving you some questions. Try to solve them. Identify leaving group and nucleophile. Okay. So our first question will be, I'm giving you this equation, this reaction. You have to identify the leaving group and what is the nucleophile here. Okay, you have to identify what is the leaving group and what is the nucleophile. We will do 2-3 examples so that you can be clear. Try to solve them. Have you copied the above thing? Sufyan, Mariam, Amna,
Yes.
Yes, sir.
have you copied these things, above thing?
Yeah.
Yes, sir.
Okay. Now try to solve these questions. Done. Sufyan, in which question you are in currently? First, second, third, fourth?
Fourth.
Mariam?
Sir, fourth one.
Amna?
Third one, sir.
Okay, no problem. You have 1 minute left. You can send me the answers. I can see it. Just send it from first ones. Nobody. You haven't sent the answers.
Sending.
Okay. Okay. So let's solve these. Amna, done? Amna. Hello. Amna. Can you hear me? Are you still there? Hello. Okay. Let's do these questions. So first one, the leaving group. We will see that in the substrate, bromine is not present in the final product. So bromine has been left this carbon. So leaving group is bromine. Is it correct for you, Mariam?
Yes, sir.
And since bromine has been left, and NO2 is acting as nucleophile. It has negative charge on it. Okay, so nucleophile is attacking on this carbon and removing this
Yes.
bromine. So NO2 minus is the nucleophile here, right? Correct.
Yes, sir.
uh, Easy one. So in the next question we can see chlorine has been removed and it has become chloride ion. So chlorine is the living group. Chlorine is the chloride ion is the living group. And what has been attached? OH minus has been attached, and since OH minus is a nucleophile here, so we'll denote it as OH minus as nucleophile. Okay.
Hmm.
Now next, what is happening? CH3O minus. ठीक है? this one is attacking on this carbon, and iodide group has been removed. So I minus has been left out, and CH3O minus has been attached. So this is methyl, right? I have not written it intentionally. You can understand it, Sufyan. This dangling thing on this
I didn't
oxygen.
see the line.
Oh, you haven't seen the line.
No.
Now can you see?
Yeah.
Mariam, can you see this line? Mariam, no, what? Mariam is gone. Amna, Amna is also gone. Okay, let it be. So now it is visible,
Yes, sir.
and it is understandable also that OCH3 has been attached, right?
Yeah.
Since it has attacked, but you can skip it. However, in the diagram also you can write it or skip it. It's your choice. So CH3O minus is the nucleophile here. Okay. Now next is this here. Can you see OH has attacked in this carbon also and this carbon also, right?
Yes, sir.
So bromine ion and iodide ion both are leaving group here, and this NOH is what? NOH is Na plus plus OH minus, right? So this is the electronucleophile here, and it has attacked on this thing also and this thing also. Okay.
Yeah.
So in this reaction, two leaving groups are present, right? Okay. So as you can till here, you understood all these problems, Sufyan?
Yeah.
So till here, you understood it's okay. So in the reaction, you can see that Rx, which is reacting with nucleophile, gives, okay, and this has been the leaving group. So as you can see, you can observe this bond is breaking, right? And this bond
Yes.
is forming. Correct? What do you think? Is it okay, Sufyan?
Yes.
So Rx bond breaks, bond breaks, and R nucleophile bond is forming. So this phenomena which has happened is can take place in two ways. So we have to discuss both ways in detail. Okay. It can be single step. It can be double step. Okay. So it can be single step reaction also, or it can be double step reaction also. Okay. So what the main thing we have to do is we have to break this Rx bond and we have to make R nucleophilic bond. So see, try to understand this mechanism. in a single step reaction, single step reaction, this nucleophile is attacking on this R. And why it is attacking? Can you tell, Sufyan?
Because it's positive charge.
Yeah, it has some
Yeah.
partial positive charge, not exactly full positive charge, partial positive charge, right?
Yeah.
So since this has attacked on this pair of electron has been taken by this leaving group. Okay, that is why, see, X has like, for example, take this as chlorine. Take real life example as chlorine. Chlorine has, this is a carbon chlorine bond. So chlorine has 7 electron, right? On the in the valence shell. Do you know chlorine has 7 electron in this valence shell?
Yeah.
So what happens? This chlorine, if it will take 1 extra electron, then it will get Cl minus charge, right?
Yes, sir.
So that is why this pair of electron has been taken by this leaving group. That is why it is getting 1 negative charge. Okay.
Yeah.
Got my point?
Yes.
So this reaction which has been taking place is dependent on this nucleophile and this substrate. Okay. So this is a single step reaction. In a single step only, the reaction has took place. So we will draw the exact diagram later. Don't worry. We are just comparing what is happening in a single step. Why are we are saying in a single step? When we will see double step reaction, then we will actually simultaneously this thing is happening. That nucleophile is attacking on this substrate, and by the time nucleophile is attacking on the substrate, the leaving group is leaving out. Okay, so the whole mechanism is taking place in a single step. Okay.
Okay.
So this is called, as you can see, this both things are dependent on the rate of reaction. So this is called bimolecular. Wait a minute. Amna, how your connection was lost?
I am having network problems, sir.
Okay. Actually, this topic will go on till next class also. So it's a very important topic. This SN1 reaction, SN2 reaction, then we will do elimination reaction. These are very important topics. So you have to be here only. Try to be, understand these concepts.
Yes, sir.
I will repeat it for you, and you, Sufyan, you will revise it. And let me know if you will have some issue. So see, I hope you have done these things, leaving group and nucleophile.
Yes, sir.
Okay. These are, in the last one, you can see this nucleophile is attacking on both things because bromine and iodine both are leaving group here. So the main thing which we are doing here is bond breaking and bond forming. Bond is breaking from the this leaving group, and new bond is forming with this nucleophile. Okay.
Yes, sir.
So what we are seeing here, that this process of bond breaking and bond forming is can be done in two ways. like in a single step reaction also, in a double step reaction also. In a single step reaction, which you can see here, the nucleophile is attacking on this R thing, which has a partial positive charge, and this leaving group is moving out simultaneously. So nucleophile is attacking, and this leaving group is getting out in a single step only. So simultaneously, both things are happening. Bond breaking thing is also happening. Bond forming thing is also happening. That is why it is called single step reaction. Okay. Have you understood this?
Yes, sir.
So this reaction rate depends upon this nucleophile also and this substrate also. That is why it is called bimolecular nucleophilic substitution, and popularly known as SN2 reaction. SN2 reaction. Okay. Since these two things, this rate is dependent on two things. That is why it is called SN2 reaction. So what is this double step thing? So let's try to understand this. Actually, in this reaction, this takes place in two steps. In first step, the leaving group, this is an equilibrium sign. In first step, this leaving group will get out and take these shared pair of electron with itself, and thus carbocation is formed, and this leaving group just move out. Okay. Have you understood this? This bond has been broken, and this shared pair of electron has been taken by this leaving group. Thus, this leaving group has got extra negative charge on it, and since the electron has been taken out from this carbon atom, thus carbocation is formed. Got it? Are you getting this step? Sufyan,
Yes, sir.
tell me, are you having some issue?
No.
Amna?
No, sir.
Okay, good. So in this step, this bond has been broken. Now, what is happening? This carbocation has been attacked by this nucleophile. Carbocation will be attacked by this nucleophile. Obviously, this is a nucleophile. This is a nucleus level thing. So this will attack on this carbocation. Okay. And what will happen? This bond will be formed. Got my point? Got my point?
Yes, sir.
Yes.
So as you can see, this reaction has been taken in two separate steps. That is why it is, double step reaction. And this reaction rate is dependent only on this substrate. This reaction rate is only dependent on this substrate. Okay. Why? Because see, the reason why this reaction is dependent on this substrate only, because this the main reason, you have to note it down. This is a very important point also. Note. Because step 1 is slow and is rate determining step. Have you heard this term, rate determining step? Anyone? I will not ask you, about this. Just I want to know, have you heard this term, rate determining step?
No,
RDS.
sir.
No, Amna.
No, sir.
Okay. Let me introduce you. What is RDS? RDS is the rate determining step. From the name, you can understand that this will only determine the, this will only determine the rate of the reaction. If this RDS will happen, means this is a kind of, like, for example, uh, have you studied this topic, chemical kinetics? Amna, Sufyan?
No, sir.
Good. Amna, have you?
Yes, sir.
Okay. You have studied in school or in this coaching?
School, sir.
School, okay. So you may remember that rate of reaction, you can see like this. The stability of this, this can be, this is reactant and this is product forming, and this is like, do you remember this graph? No problem. See, you try to understand. Like, no, this graph will be more appropriate for this thing. Just what I want to say, what I want to say in this graph, that this reaction have to, since this reaction, this reactant have to go to this product, have to, want to become a product. So it has to cross a, you know, a, a big thermal difference from here to here, energy difference. So the energy difference is very high. So do you remember we apply a catalyst and, you know, this reduces and product will form easily? Do you remember? If you don't remember, no problem, just say it.
Can you repeat?
That if the reactants and product, thermal stability has been, the graph is this, but if we will add catalyst, it will form like this, the new
Yeah.
one. So I'm not, no problem if you are not understanding, just try to understand this, that to form a product, it has to cross this, this big energy difference. Okay, these much big energy difference. So the RDS is the step where energy difference is very high. This is the actual, this will determine the reaction will take place or not, or what will be the rate of reaction. Okay, because this step will not, this step will take place very, uh, suddenly. That step is very sudden, so we don't have to worry about this step. Our, main concern is this, that we have to make this RDS, rate determining step. Okay, what is the rate determining step? That is our main concern. Okay, Sufyan? Shall I try to, make you understand in different way? Just tell me if you are having doubt. No problem. Amna,
Yes, sir.
see. Sufyan, you got this graph? You have understood
Yeah.
this graph?
Yes, sir.
Rate determining step. By, see, by the definition, you have to understand that it has been, you have to understand from chemical kinetics point of view, but you don't have to go in much detail that what is rate determining step. I'm not getting. Just you have to understand that uh, actually in a reaction, you have understood that. Have you studied elementary step?
No.
It was in chemical kinetics things. No problem. We will teach you there. Now you will understand each and every step. So don't worry about this. Okay. So I'm just, will refer later that a reaction has to go through several ups and down. Okay. If it is a complex reaction. Oh. Excellent. If it is a complex reaction, see, this is a very complex reaction. Uh, you both have missed the last class where I have talked about intermediates. No, actually, I have So, like for example, here is the reactant and here is the product. Actually, uh, many things are forming in between. We before forming the product, many different things are forming. For example, in this thing, can you see carbocation here? Do you know what is carbocation?
Yes, sir.
Sufyan, Amna?
Yes, sir.
So can you see in the product? Can you see in the product carbocation is there?
Yes.
Amna, can you see carbocation here?
Yes, sir.
So carbocation, it has to be a cation. There is no cation. Actually, this is a neutral product. Carbocation is present here only. Okay, this is very clear cut carbocation. Carbocation is a carbon which has a positive charge on it, like this. Or example, I'm giving you CH3 CH2 plus. These are carbocation, okay? Or simply you can say R plus. So here you cannot see carbocation, right? Are you
Yes,
getting?
Yes,
sir.
sir.
So but carbocation is formed in the reaction. Can you see in this reaction? This is a complex reaction. This is a two-step reaction. Can you see carbocation is forming in one of the reaction?
Yeah.
Anna, can you see?
Yes, sir.
But still we cannot see in the product because this is a intermediate. This is a maybe a new term for you. This is a intermediate. This is an intermediate. So this is forming, but we cannot see it. So what is happening? That in between somewhere carbocation has been formed. Okay. In between somewhere carbocation is formed. That is why we cannot see it. And this is very, you know, uh, unstable thing. Do you always remember that neutral species are always stable than any ion? Do you know that neutral species are always stable than any ion?
Yes.
Now, what do you think? Neutral species will be more stable or cation or anion?
Neutral.
Neutral. Amna,
Neutral.
good. Good. So actually, these things are not formed. Okay, these are formed in between a reaction. So these are intermediates. Okay, and they are very unstable. So these steps are very slow. That is why it is called rate determining step. if you are not getting these graphs, there is no issue with it. Just leave it aside and focus here. Okay, these are for to relate those things and have some knowledge according to this whole subject knowledge. But no problem, when we will discuss na chemical kinetics here, so we will get into whole detail what this step is called, what is happening here, what is the difference here and here. Okay, so don't worry. Sufyan, are you having some trouble?
Yes, sir.
Okay.
Huh?
Okay, so now you understood this thing.
Yes, sir.
Okay, so rate determining step is this formation of step 1 is slow, and is the rate determining step, is the rate determining step, which is formation of carbocation. Okay, the formation of this carbocation is the rate determining step. This is what I have written in this note. Okay, understood, Sufyan?
Yes, sir.
Okay, we will go into detail with this SN1 and SN2 reaction again, so you don't have to worry. And this is popularly known as SN1 reaction. This is popularly known as SN1 reaction, and this is SN2 reaction. SN2 reaction is single step, SN1 reaction is a double step, and we will go into detail. Don't worry, we will write each about uh, each one of them. First we will discuss SN1 reaction. Okay, so what let's write the points, some points here, important points. Refers to unimolecular. Have you noted these down? The above thing?
Yes, sir.
Sufyan?
No.
Okay, write it down, write it down. Done.
Yes, sir.
We will draw the actual diagram of it in the mechanism part, and we will understand it. Okay, Amna, have you written those down? Written these down?
Yes, sir.
See, so it is a unimolecular nucleophilic reaction, substitution, because only one molecule, the rate is dependent on one molecule only, and this depends upon the concentration of substrate only, as we have discussed, because only first step is the rate determining step. And you can see these thing only. So order is 1 from the chemical kinetics. As you see, the this is 1 here, so order will be is 1, right? And only one molecule is the rate is dependent on only one molecule, so molecularity is also 1. Okay, got it?
Yes, sir.
Okay, now now we will see the mechanism. Now we will see the mechanism. So what the mechanism is. So it occurs in two. Okay, first. So in the first step, this bond has been broken, right? This bond has been broken.
Yes, sir.
This and carbocation is formed. So that is why we have written it or here, that breaking of CX bond or formation of carbocation. And this is more popular, that formation of carbocation is the first step. So see the diagram in the CX thing. This is these 1, 2, 3 things can be hydrogen also, can be CH3 also. Okay, can be anything. This is the alkyl group. Okay.
Yeah.
So let's draw a the equilibrium reaction, which is a slow step, and equilibrium reaction are slow reactions, slow steps. So what is happening? This carbocation is formed. Okay. We have drawn this. This carbocation is formed, and here 1, 2, 3. See, carbocation is this carbocation is sp2 hybridized. Can you see this? Wait, let me. This is sp2 hybridized. Okay, so that is why its structure is like this. sp2 hybridization, in hybridization thing, do you remember?
Yes, sir.
sp2 is 120 degree from all three sides.
Yes.
So this is a 1, 2, 3 are in a plane, and this is attached with carbon. Okay. Okay. Hello, Amna.
Yes, sir.
So you got this point, that this this left this out, and this carbocation is formed, and the structure will be like this, right?
Yes, sir.
Secondly, after this, attack of nucleophile will attack on it, and see the magic will happen. What will happen? See, very important thing will happen. This carbon, this nucleophile, let's copy this. See what will happen. This is a nucleophile. Okay, so it has the option to attack on this also, this side also, or this side also. And draw with a different color. Nucleophile can attack from this position also, this position also. Why? Because this is in a plane. Oh, अच्छा ये copy हो गया है. Okay. Wait a minute. You note down these things. I'm going to, are you copying? Amna, are you copying?
Yes.
Copy. Once I will make the diagram, then I will explain. Done copying till here?
Yes, sir.
Sufyan, Sufyan,
Yes, sir.
done copying?
Yeah.
Okay, so let's start. So what are the options available? That this nucleophile has the option to attack from this side, okay, this side, or it can attack from the bottom side. Okay, so there are two options available for it. So what can happen? What can happen? This two type. Have you studied this isomers
Yes.
in 11th class, right?
Yeah.
Okay, no problem. So see, so there are two options that it can form. The first option will be in this, this, like this. Let me draw it for you. So when the nucleophile will attack from upper side, so it will first, second, third, and the nucleophile will be in this position. Okay, and the second option will be that this carbon, since nucleophile has been attacked from downside, so nucleophile will attach from this side. Okay, got my point?
Yes, sir.
So what is happening? This, you have to see this thing, that this leaving group has been gone, right? And nucleophile has attacked from this side and this back side. Okay, there are two options available, from this side and this side, right? So if it will attach from this side only, on the same side, from the earlier side only where the leaving group was present, so from that side, this will be called as retention. This will be called as retention. Means the retention, the structure was retained, the structural isomerism was retained. And if the if it is attacked from the behind side, like for example, it has been attached from this side, if it will attack from this side, this one group will be form here, two will form here, and three will form here. Got my point? Amna, see, if the nucleophile will attack from this side, this one will come here, one this side, two will come here, and three will come here. Okay, are you getting this?
Sir.
Amna, inversion. So this is called inversion. Inversion will take place. Okay, means the structure has been inverted. Like it was in this position, it has been inverted. Okay, are you getting this? Sufyan, are you having some problem, doubt? You can make me. I can repeat it for you, or you are having some problem in any step, exact step. You can tell me.
No.
Huh?
No, sure.
No problem. Okay. So this retention and inversion means in a mixture, when this reaction took place, we have 50% of this compound and 50% of this compound. Okay.
Yeah.
Okay. So finally, this, when we have this kind of mixture is called racemic mixture. Racemic mixture. Have you heard this term before?
Yes, sir.
No.
Yes.
Acha, you have heard this. So great. So you got this point, that if we have two optical isomers, get racemic mixtures, right? It the first one will rotate in clockwise direction, and the second one will rotate it in anti-clockwise direction. That is why it is called as a racemic mixture. Okay.
Yeah.
Ha. Okay. So the optical activity of this whole thing, the whole thing will be zero, because 50% will rotate in clockwise direction and other 50% will rotate in anti-clockwise direction. So the the optical this will be optically inactive. Optically inactive. The optical mixtures are optically inactive. Do you remember this?
No.
Okay, no problem. So tell me, have you understood till here?
So,
Any doubt? Hmm. Any doubt till here?
no, sir.
So this uh, so till here we are done. Now we will just write those things which we have learned, and we will finish the class. So I've already written rate of. Acha, I will write this down again. This is a very important point. Note. Have you copied this thing?
Yes.
Okay. So rate of SN1 reaction is dependent on stability of carbocation. Okay. So more the stable carbocation is, more will be the rate of reaction. So that is it. I think from the diagram you can see retention and inversion happen. Okay. And in the two steps we have done this reaction. In first step carbocation is formed, and in second step nucleophile is attacking, and it has the ability to attack from both sides. And if the nucleophile has attacked from the and formed the product which is having the same structure as it was of the original substrate, that will be called as retention, because the original original compound structure has been retained. And if it attacked from different position, inversion is caused. Okay, can you see me, Sufyan?
Yes.
Okay, see, wait, let me check my camera. Okay, can you see this?
Yes.
Sufyan, see, can you this is a leaving group, the colored pen. Can you see this?
सीधा बुक करने जाना है
Yes.
अंडे बाजार
Sufyan,
Yes, sir.
can you see this
बुक
X
करना
thing, this pen?
Yes.
This is a leaving group. This has been